students, and welcome to this video where we're going to discuss dot product. I'm going to begin by writing a definition. So we're going to let vector v, we're going to call its values a1 and b1, and a second vector w, we'll call its parts a2 and b2. If we have these two vectors, the dot product is represented by v dot w, showing our dot product notation, a1 times a2 plus b1 times b2. And I want to make sure it's very clear that whenever you find the dot product, it produces a scalar. Okay? All right, so for example, let's suppose that we have vector v, which is 3, negative 7, and we have vector w, which is negative 2, 5. And let's say I ask you to find a few different things. Let's start out by finding the dot product of v times w. So that's going to be 3 times negative 2 plus negative 7 times 5. And that's going to produce a solution of negative 41. Okay. I'm going to encourage you to pause this video and try to find this next one on your own. This is going to be the dot product of w times v. You should have gotten that the dot product is negative 41. And if you compare the two dot products that we just found, you can see that we got the same solution. And you can see that all we did was switch the places of v and w. Thus, what we see from this is that dot product is commutative. So it means switching the order is okay. You are going to produce the same solution. I'm going to again encourage you to pause this video and try this one on your own. Find the dot product of v dot v. Finding the dot product of v dot v, you should have ended up with 58. Okay? All right, another thing that we want to be able to successfully do in this section is be able to find the angle between vectors. So I'm going to begin by drawing a picture just so you're kind of visualizing what we're working with here. So I'm going to begin by drawing vector v. V is in orange. I'm going to draw another vector here in blue. This is going to be my, actually let me switch these. I'm going to make this one v and I'm going to make this one w. And then here would represent my v minus w. Okay? And my angle measurement, my theta, would be right here. So just so you have a picture to visualize. So a little formula that you want to keep in mind is, and we're using an essence of the law of cosines, cosine theta of v dot w all over the magnitude of v times the magnitude of w. And if you're trying to isolate theta by itself, you would have to do cosine inverse of the dot product of v and w all over their respective magnitudes. Okay? So just kind of good to keep in mind as we go through some examples. So on this very first example, I want you to find theta, and v is going to equal negative 4, 3, and w is going to equal negative 6, negative 2. Now I feel confident you should be able to find the different parts on your own, so I'm going to encourage you to pause this video. The first thing you want to do is find the dot product. The next thing you want to do is find the magnitude of v, and you want to find the magnitude of w. Again, I'd encourage you to pause this video and resume once you feel you have the solution. The dot product of v times w is going to create 24 minus 6, and that's going to be equal to, not negative, excuse me, that would be positive 18. The magnitude of V, plugging that into the respective formula. Let's see, we're going to have negative 4 squared plus 3 squared, which gets us the square root of 25, which is just 5. And for W, you're going to have to reduce the 40. So just kind of thinking about two numbers that multiplied to 40 would be 4 and 10. 4 would be 2 and 2. 10 would be 5 and 2. There's a group. So I can take that to the outside, and I have square roots of 10 left over. Awesome. Now we can take all of that information and plug that in to find our theta. So we have cosine inverse of our dot product, which is 18 all over 5 times 2 square roots of 10, which is 10 square roots of 10. You can go ahead and plug that into your calculator, ensure that you're in degree mode, and you should end up with 55.3 degrees. Okay? Now, there's a note that I'd like to make. This just kind of helps you to think about what's occurring and what you should get. So it's related to the dot product when you know that the dot product is either greater than 0, when it's less than 0, or if the dot product is equal to 0. If the dot product is greater than 0, then that means your cosine of theta is going to be greater than 0, and you're going to occur in quadrant 1, meaning between 0 and 90 degrees. Whereas if your dot product is less than 0, your cosine of theta is going to be also less than 0, and so you're going to appear in quadrant 2, meaning you're between 90 and 180 degrees. If your dot product is equal to 0, then that means cosine of theta is also going to equal 0. So that means your theta value is equal to exactly 90 degrees. And I'm going to highlight this last statement because this is actually a special case. When the dot product of V and W equals 0, that lets you know that V and W are orthogonal. When you use the word orthogonal, you're essentially saying that they are perpendicular. We just don't use the word perpendicular when we're referring to vectors. I don't really have an explanation as to why we don't use the word. We just kind of don't in the math world. But they are synonymous to one another. So when we're talking about perpendicular vectors, we'll always use the word orthogonal. Okay? So with that being said, sometimes you do want to identify are two values or two vectors orthogonal to one another. So I'm giving you two vectors in the form of I and j, and I would like you to tell me if you think these are orthogonal to one another. So I'm going to find their dot product. In order for them to, this is what I'm trying to prove, their dot product has to equal 0. So I'm going to go ahead and calculate the dot product here. Which does in fact equal 0. Thus, these would be orthogonal vectors. I can give you another one to just try on your own. Again, as always, I encourage you to pause this video and see if you can do this on your own. You end up with a final value of negative 32. Looking at that value, it does not equal 0. Thus, S and R are not orthogonal vectors. Okay? As always, I hope you found this video helpful. If you have any questions or concerns, please don't hesitate to reach out, and have an awesome rest of your day.